Today we're going to be looking at the history of measuring the speed of light, and in the description you'll find a link to flashcards. So we're going to take you from ancient times through to the modern day approach to measuring the speed of light, and just demonstrate how that change in value of what's been accepted from spontaneous through to 3 times 10 to the power of 8 meters per second for the speed of light has changed over time. So as I just mentioned, in ancient times, scientists actually believed the speed of light to be infinite. This means it's pretty much instantaneous. So the first name for the HSC we have to worry about is Galileo Galilei. So in the 17th century, he measured the speed of light, and essentially he got his assistant to stand on a distant hill while he opened a lantern, and they tried to time how long it took that light to travel between the 2 points. So obviously this was a very not effective way of measuring the speed of light. However, it did kind of mark the first time people no longer thought of the speed of light as being spontaneous or instant. So from here, Galileo actually would be able to determine the speed of light to be finite, and he essentially was able to note a difference in the time it took one of the moons of Jupiter to orbit. So he noticed a difference depending on the position of Earth to this moon. And what this would mean is that that time difference meant that the light was actually traveling a different length path, depending on how the orbits of the moon and Earth lined up. So now we're going to kind of take a next step, which is in essence looking at how we have modern day, or at least 1850s techniques to measure the speed of light. So you can actually see that the speed of light here was pretty close. So this is when they were starting to really hit the ballpark. And what they did was they would shine light through this, and it would bounce off this mirror and back through, and they'd have it so that this gear here was turning. And while this took one tooth essentially spacing, they were able to then use some of the circular motion physics. We'll be looking at that later on. And they were able to determine how fast this light was going based on the time it took it to travel this distance and back, because that would be when it turned one tooth over. So they could actually measure the speed of light by varying the speed this wheel is turning. So Leon Foucault then improved upon this, and you can see how close his timing was actually. So we're now seeing some error of plus or minus 51 kilometers per second, which is pretty impressive when you think of the magnitude of the speed of light. So 13 years later, Foucault did this experiment whereby he looked at the change in angle, and similar approach as what we just saw over here. But this change in angle was what gave him the ability to improve on Fiers's apparatus. Sorry. So from here, Albert Michelson, he may hear in reference to the ether, but he also created an 8-sided rotating mirror apparatus, and this gave him this incredibly accurate reading. So it's precise in essence because it's very close to the modern day accepted value. And this was in the 1920s. Then we have modern day, which is the International Commission on Weights and Measures. And they basically use a lot of vacuums and mirrors in order to measure the speed of light. So this value here is what the modern day accepted value is. And that approximates to about 7.5 trips around the Earth every second.